using WarpPLS. Good evening, good afternoon, good morning, based on where you are. I'm Dr. Mustafa Rasuli Manish from School of Hospitality, Tourism and Event, Taylor's University. This course actually is on PLS-SEM using WarpPLS-7. And this is a course that's offered by our school of Hospitality, Tourism and Event, and Taylor's University. So in this course, actually, we will discuss in 4 sessions, and we will cover 4 actually main areas. First session, we will focus on introduction, introduction to PLS and WarpPLS. Creating a model in WarpPLS and assessment of measurement model and a structural model in WarpPLS. We'll try to discover some specific features of WarpPLS that is different with the other software, and the nonlinear option of WarpPLS. Then we will, in next session, we will focus on assessment of higher order construct, actually hypothesizing an assessment of a higher order construct, and see how we can define higher order construct in WarpPLS and how we can assess it. In the third session, we will focus on the mediator. Try to discover some features about mediator in WarpPLS, especially related to complex mediator. WarpPLS has some good feature to discover, to investigate, and to test mediator and moderator. So we will actually discover together some of these features in WarpPLS in third session about mediator, and last session will focus on moderator and multi-group analysis. Also, I will try to cover some advanced feature like moderated mediation using WarpPLS in last session. Okay, so, but before starting and go through a slide and using software, let me show you something on WarpPLS. Actually, this is a website of WarpPLS. You can download WarpPLS software from this website. Here you can see a figure from WarpPLS. Actually, WarpPLS is known as a non-linear software, non-linear PLS software. So here you can see a curve that we can get from WarpPLS. Later, I will show you how we can get this plot from WarpPLS based on our result. In this website, you can find many different information. Actually, the WarpPLS software was developed by Professor Netcock. Here you can see the original version of the WarpPLS was developed in 2009, WarpPLS 1, and other different versions actually were developed in different years, and the latest version is WarpPLS 7, released in 2020. So the latest version of WarpPLS is WarpPLS 7. Here you can see some features of WarpPLS, very briefly explain about this feature. And in website, you can find some useful information like some YouTube videos. Here there are many good YouTube videos by mostly by Professor Netcore. Here you can see some training that's available. Okay, if you click on training, also you can see some name here. Also my name is here. Yeah, I regularly conduct WarpPLS workshop and training online or face-to-face. Here you can find also some publications on some publications using WarpPLS. So if you click on publication, you can see if, many publication, methodological publication, philosophical and methodological foundation of WarpPLS, empirical studies, some empirical studies using WarpPLS. So you can download this paper and use as a reference for go through. Here you can find some doctoral dissertation or thesis that uses WarpPLS. There are some data set here. You can use these data set. There is also WarpPLS weblog. In this blog, Professor Netcock provides some when he actually prepared some videos or some notes post in this weblog, so you can get useful information about WarpPLS and PLS in general. So in the website, you can get good information in general about PLS-SEM and also WarpPLS software. As I in instruction and welcome note, I mentioned here you can from the website. I provided the link. So from the this website you can download WarpPLS 7 latest version. There are two options to download WarpPLS. One is for current WarpPLS user. So if you are a current WarpPLS user, you use the other version before. So you can click on this link and download the very small file and update actually WarpPLS, your previous version to WarpPLS 7. But if you are a new user, you have to download from this one of these links. And when you download from one of these links, you can actually for first time install in your computer and use this software. For first time, when you download WarpPLS and install in your system, WarpPLS give you a 3 months trial version, and this trial version is a full function version. So you can perform all the types of analysis, and you can actually use all features available in WarpPLS in this trial version. So you can use it for 3 months, but after 3 months, you need to purchase a license to continue using WarpPLS. So this is some basic information about WarpPLS and how we can install and start to use. Okay. But let me go through a slide and very briefly before starting to use software, give you some basic information and introduction to PLS. Actually, if you register in and enroll in Times in Taylor's University platform, you have access to this slide. In this slide, in detail, I discuss some area and some topics related to SEM, differences between two types of SEM, covariance-based SEM and variance-based SEM or PLS-SEM. different types of variable, formative, reflective, and composite variable, and some basic information. But actually in this session, I'm not going through this basic information. If you are interested to know, you can watch introduction to Smart PLS, PLS-SEM using a Smart PLS. In first part of that course, actually, and in first session, I discuss all this part in detail. So for this PLS course, I'm not going through these different basic part. And I'm I will start from assessment of measurement model and assessment of structural model. Very briefly, we'll go through assessment of measurement model and structural model using PLS-SEM, and then I will start work with the software. Okay, for assessment of measurement model and structural model and reporting result of PLS-SEM, there are many good papers and guidelines. This is one of the papers. This is our paper that we published in 2018. And here we provided a guideline to report, to apply and report PLS-SEM result. So this paper won Emerald Literature Award 2019 as an outstanding paper. So you can go through this paper. Here we provided a very clear guideline and simple guideline to follow. Another paper that recently published by Professor Hare and his colleague, this paper went to use and how to report result of PLS-SEM, published in 2019. So this is two samples of papers that provided guideline, but there are many. But the most important things, you have to follow recent guideline for assessment of your model, your framework using PLS-SEM and reporting the result. So if you apply PLS, doesn't matter what software. All software, actually, we can get similar result from all software. So you need to follow recent guideline to conduct the different part of assessment and to report the result, right? So you can follow these two paper or any other recent guideline to assess model using PLS-SEM and report the result. Actually, PLS, when we apply PLS, we need to follow two steps. We need to assess measurement model and we need to assess structural model. And for assessment of measurement model and structural model, based on, especially for measurement model, based on the type of construct that we have, actually we need to apply different criteria. If our construct is reflective, we need to check indicator reliability, we need to check internal consistency or construct reliability using composite reliability, Cronbach and ROA. ROA is in another criterion to assess internal consistency and construct reliability developed in recent years. We need to check convergent validity using AVE, average variance extracted, and we need to check discriminant validity. Traditional way to assess discriminant validity is using cross-loading and Follner-Larker criteria. But in recent year, in 2015, another criterion, heterotrait monotrait ratio, was developed by Jörg Hensler and his colleague. And based on some recent study, this approach actually is more reliable approach to assess the discriminant validity. So it's acceptable, more acceptable compared to other two approaches. But some study suggested to apply HTMT ratio and Fornell Larker together. So this is some methods or criteria to assess discriminant validity. But actually, there is another criterion to assess discriminant validity called full collinearity. There's not much literature about full collinearity, but WarpPLS software is only software that provide the result of full collinearity. And this actually criterion can be used to assess discriminant validity, especially when we have formative construct in our framework. So far, based on other three criteria, we cannot assess discriminant validity of formative construct. These three criteria only can be applied for reflective construct. So if we have formative construct, one of construct, two of construct in our framework is formative, actually we are not able to assess discriminant validity based on three criteria. But the full collinearity is a construct-based criterion to assess, actually can be used for assessment of discriminant validity. We presented the paper in PLS-17 3 years ago, and we did a simulation study. And in this study, actually, we show that the full collinearity can be used for assessment of discriminant validity, especially when we have formative construct. Actually, in that simulation, we show that even for reflective construct with threshold of 3.3, full collinearity can be used and is actually comparable with the HTMT result. But of course, need much more work and a simulation study to confirm full collinearity as an acceptable criterion for assessment of discriminant validity. So for indicator reliability, we need to check the loading of the reflective construct, and the loading should be at least higher than 0.5. If it's lower than 0.5, we have to delete it. If it's between 0.5 and 7, we need to look at other criteria for convergent validity and construct reliability, right, like CR and ADE, to check whether we should delete this item or can retain it. For internal consistency, Kernbach alpha, composite reliability, and ρA should be higher than 0.7. And the ADE for convergent validity should be higher than 0.5 to fulfill, to establish convergent validity. And for discriminant validity, as I mentioned, these three, for Fornell Larker criterion, the square root of ADE should be higher than correlation of each construct with other construct, or ADE should be higher than squared correlation between construct. For heterotrait monotrait, ratio is calculated based on this formula, right? But the value of HTMT should be higher than 0.85 or 0.9 to establish discriminant validity. Should be lower than 0.85 or 0.9 to establish discriminant validity. But actually, recently another criterion was developed to assess the HTMT. And based on this, we check significance of the HTMT compared to 1. So if HTMT is lower than 1 significantly, we can conclude, we can establish discriminant validity. So for this one, we check actually the confidence interval, and if confidence interval for HTMT is not included 1, so we can conclude that or upper level is lower than 1, so we can conclude and we can establish discriminant validity. But this actually criterion is more liberal criterion compared to 0.85 and 0.9. And 0.85 is more conservative criterion for assessment of discriminant validity. Okay, here is some is criteria for assessment of formative construct. Actually, for formative, we need to check external validity or redundancy analysis. We need to check VIF, variance inflation factor, and VIF, multicollinearity VIF should be higher than, should be lower than 5. Should be lower than 5. And for formative, actually, we need to check significance of outer weight to assess formative measurement. Okay, for composite construct, addition to 2 criteria, collinearity VIF and weight, significance of weight, we need to check nomological validity. And okay, and actually another criteria that I mentioned is full collinearity for especially when we have formative construct. This is the formula for calculating VIF or collinearity. Full collinearity is actually both lateral and vertical collinearity. At the moment when we talk about multicollinearity in a structural level, we check only vertical collinearity. But Koch and Lin 2012 published a paper and they actually introduced full collinearity. And this full collinearity include all construct involved in model, involved in our framework, and actually calculate VIF, collinearity VIF for all construct. So based on their discussion and in that paper, and some of the discussion that if you are interested, you can go through our paper. Actually, this is result of our simulation from our paper that we presented in PLS-17 in 2017. I uploaded this paper in Times. So you have access to a folder called literature, and in this folder you can find this paper. If you are interested to see and know how full collinearity actually can be used for assessment of discriminant validity, you can go through that paper. But here actually we provided some evidences that full collinearity can be good criterion to assess discriminant validity, especially when formative construct involved in model. And the assessment of a structural model, actually we need to fulfill a few criteria. Most common criteria or assessment of R-square and size and sign of and significance of height coefficient, effect size, and the predictive relevance Q square. But you know, the recent literature also suggests to apply out of sample prediction using PLS predict. But the PLS predict is not still available in WarpPLS. But all other these criteria can be calculated using WarpPLS. So I'm not actually going through this detailed explanation, and I prefer. Okay, here you can see some plot from WarpPLS. Later, I will show you how we can get this plot for a relationship between construct. And actually, this is one of the feature of WarpPLS, unique feature of WarpPLS. So if you have some relationship, especially some relationship that's supported by literature, and this relationship in the literature are nonlinear, WarpPLS can be very, very good choice for your study. Okay, later I will show you first page of WarpPLS, right? Yes. Can confirm it if you.
Yes, it can be seen.
Yes. Okay. So you can see when you install WarpPLS, you can see this page when you use for first time. So you can activate tutorial version. I'm using also tutorial version of WarpPLS. So this tutorial version is active for 3 months. If you get new license, you can click on submit new license and actually key in license, new license, and use a new actually software with your license. But if you are using this trial version for 3 months, you can proceed to use software. So if you click on proceed to use software, you will transfer to, okay. So this is the main page of WarpPLS when you proceed to use software and you want to create your model and analyze it and get the result. Okay, here you can see some information. WarpPLS developed by Netcook and use MATLAB and C++ and Java. And there are actually 5 steps, very simple steps, and something happen in each step. So we will do different steps and show you what we need to do in each step to create and analyze our model. Step 1, when you click on step 1 is to open your project file or create new project. If you already had a file, you already created a file and analyze your framework. So only you need to click on open project file and use or open available project. Actually, the WarpPLS creates a file with extension of PRJ, a project PRJ, and this file will be very small file, if maybe 300, 400 K, but this file actually include all information that you need and also your data set. So this is one of the advantage of WarpPLS. So all these information available in this small project file, right? So you can send to your friend, you can send to anybody you want, and others using this file can open your project and can see your data file and all information that you have in this file, right? So all is accumulated in one small file with extension of the project PRJ. Okay, this is the first thing. But we need to create it. So proceed to step 1, and then click on create project file. And so you need to select the folder that you want to save your file. Okay, here the name of this project is online course, for example, var. Okay, so I save this one. So first step is done. All right. Now we go to step 2. Proceed to a step 2. So a step 2 is to read file. Also, we can copy and paste from clipboard. All right. But here we choose this read file. Here we have another difference with some software. In WarpPLS, actually, it's possible to read different types of Excel file, tab delimited file, and comma delimited file. But you know, in for example, SmartPLS only we can read the comma delimited file, right? But here we have more option to read our data set. So when click on read from file, here I have data set, but it doesn't show anything because here the extension is only text file. But if I change to all file, I can see my file here. So click on data set for webinar and click on open. Okay. Just click on next and finish. Okay. So here you can see your data file. You can check your data file if there is any problem or so. In this step, you can check your original file. This is your original file, right? But if your data look correct, you can click on yes. And then you can go to step 3. So we already done 2 steps. Click on step 3. In step 3, some pre-process data is done. So if you click on pre-process data, here check for missing value and 0 variance and identical column name. And then finally, standardize your data. And when you click on OK, you can see standardized data. So here you can check standardized data. And actually, your data, right? For example, dealing with missing value. If there is any missing value, using different approach and algorithm, your missing value in the last step will be replaced. So here in this step, you don't have any missing value. Replace using mean or other approach. You can actually select method for missing value imputation. Okay, so here you can see standardized data, and if your data is correct, you can just click on yes and continue. So 3 steps was done. So you can go to step 4. Step 4 actually is step that you create your model, define SEM model. So you can click on define SEM model. When you click on define SEM, here you have some options. Model option. Still, we haven't created our model. Latent variable option is to create latent variable, edit, delete, and move latent variable. Direct link option is to create direct link or delete it. Moderating link is to create moderating So option from help, actually you can open the user manual of WarpPLS videos. So here connect to some videos, and also you can connect to WarpPLS blog. Okay, so we need to use this latent variable option. This is we want to create a framework including 5 antecedent or exogenous variable and 1 endogenous: community attachment, environmental attitude, cultural attitude, involvement, and economic gain influence on support, right? So we want to create this framework. So we have 5 independent variable or endogenous. So when we click on latent variable option, first is create latent variable. You need to click on create latent variable and click on this white window. Okay. So when you click, you will transfer to this part, right? Okay. Here you can define the name of your variable, but the name only can be 8 characters. For example, first one is community attachment. So then this is the name of first construct, right? In this part, you have name of all indicators. So for community attachment, here we have 4 indicators or 4 items for community attachment. So you need to click on 4 items. And when you click on each item, this item will transfer to this part, right? Transfer to left side. If you want to remove one item, just you can click on remove in this part. But I want to add again. Here you can choose the type of your construct, formative or reflective. So you can change to reflective, or you can keep formative. Default is reflective. So when you transfer indicator for community attachment, you need to click on save latent variable. Okay, so the variable will be appear here. We will create another variable, same way, environmental attitude. So we have environmental attitude. Third variable is community attachment. Say another variable is involvement. And the last independent variable is economic gain. So we can add economic gain. Okay. And if you click on each construct, you can move by clicking on construct any place you want, right? So you can, okay. Then the last construct is support. So I create support based on indicator support. So we have 5 indicators for support, and support also is reflective construct. So we have 5 construct here. Okay. For a link between a construct, we need to create on this create link, right? And for each link, you need to click on create direct link. So you need to click on the first construct and the construct that this arrow points to this construct. So you will see this arrow. Okay. Okay. But just I put arrow for this tree construct and I don't connect these two constructs to support. Okay. And want to continue. When you complete your framework, you can save and close. And then proceed to step 5. In step 5, we perform SEM analysis. We perform SEM analysis. Click on perform. Okay. You can see the result. Okay, there are some points here. One, here you can see we didn't connect two of constructs to dependent variable or endogenous variable. But still, WarpPLS can calculate measurement model and also structural model for the path that we created. This is not possible in other software, especially some well-known software that we know. This is the reason for this one is actually WarpPLS for assessment of outer model and for outer model algorithm, there are some options that based on this option, we don't need connection between all constructs. If we choose these options, actually the model can be performed, analysis can be performed even without link and connection between constructs, right? This option, okay, if we go to this option here, when you analyze our model, okay, when we perform analysis, we can see the result here, view or save result, right? Okay, so if here we have some options. One of the important options is setting option. Okay. Setting option, we have many different things. I don't want to go through all the options we have here, but the first option here is outer model analysis algorithm. WarpPLS actually provide many different algorithms for outer model, not only mode A or mode B. You know, in traditional PLS, we have mode A for reflective construct and mode B for formative construct. So we have to choose mode A and mode B. And mode A and mode B, actually, mode A and mode B algorithm depend on nomonological relationship between constructs. So if we choose mode A and mode B, you can see it's not possible. We are not able to run a model without link between all constructs. At least we need one link between two constructs, right? So at least one construct should be connected to another one construct. right? So without link between all constructs, it's not possible to run traditional PLS. But here in WarpPLS, you can see it's possible because we didn't have we didn't have relationship, we didn't connect involvement and economic gain to support. And still, the analysis is performed. Okay, this is because of this algorithm. The default algorithm for outer model for WarpPLS is PLS regression. Also, you can change to PLS mode A, PLS mode B, and many other options. These options are factor-based or similar or close to fact. You can get close result close to factor-based analysis using these options. So there are these algorithms different with traditional algorithm, and we can get the result similar to common base analysis, common factor-based analysis. Okay, but when we choose PLS regression, so it's possible to run model without linkage, without connection between constructs. So this is another difference of WarpPLS with some other software. Apply traditional PLS algorithm. Okay, if we click on, if we want to change our framework, we want to do some modification in our framework, we need to go to step 4, to go back to step 4. So if we click on step 4, define model. Okay, I want to just connect the other two constructs to support. Okay, and now save and close. Proceed to step 5. Okay, here you have the result. Another actually characteristic of WarpPLS, here you can see path coefficient or beta coefficient and p-value. So no need to run bootstrapping in another step to get significance of parameters, significance of path coefficient, significance of loading or weight. In one go, in one run, you can actually get result, basic result, and result of assessment of significance of different criteria, significance of path coefficient or other parameters. So you don't need to run PLS algorithm and then bootstrapping separately. So you can get the result together, right? So this is another difference between WarpPLS and some other software. Okay, so when you run analysis, here in view, you can get many different results. Okay, result here actually are applied for assessment of different criteria, assessment of mediator, assessment of moderator, direct link, or I will show you some of them, especially in this session, for assessment of measurement model and structural model, basic assessment. In first part, you can view general results. You can see the version of WarpPLS, some basic information about your file and software. Here you can see some general model elements, outer model algorithm, inner model algorithm. Here you can see warp3. Later I will show you what's the meaning of this warp3. Resampling method. In WarpPLS, we can apply, actually, we can use different resampling method, not only bootstrapping. We can use bootstrapping, jackknifing, or stable resampling. that use logarithmic algorithm to for resampling. And some other information. You can get this information from this part. Okay. But for assessment of measurement model and structural model, we need to check the loading for indicator reliability. The first step of assessment of reflective construct is assessment of to check the loading, right? Okay. To check the loading, we need to come to this option, view indicator loading and cross loading. But here in indicator loading and cross loading, you have different result based on different various algorithms. The first one is the best for basic assessment of the model is combined loading and cross loading. And in this table, in combined loading and cross loading option, you can see outer loading of indicator of each construct within bracket, within parentheses. So these four are outer loading of CA1 to CA4, CA1, 2, 3, 4, items of community attachment. But here in second column, EA1, EA2, 3, within parentheses, within bracket, you can see items of environmental attitude, cultural attitude, and involvement. Okay, for example, for community attachment, you can see the loading, except the CA3, all are higher than 0.7. So to decide about CA3, we need to check CR and ABE. And for second one, environmental attitude, 3 items are within parentheses are higher than 0.7. Okay. So here you can check loading for items of your construct. In this column, actually you can see, in this column you can see type of construct, right? Type of construct, all are reflective. Here also provide the standard error and also p-value for all loading, outer loading. So here you can see p-value for loading, standard error, and the type of construct. And for each item also you can see cross-loading with other construct. Okay, for example, this one is cross-loading of CA2 with environmental attitude. This one is cross-loading with cultural attitude. So from this table, actually, you can get result of outer loading for assessment of first step of assessment of measurement model of reflective. This is the first step. Okay, one question. You can follow all these steps that I show you, and you can see in your anybody can someone can answer?
Yes, Prof. I can see what
you can see all the steps, and you can follow me different tab that I open and explain. You can follow all, right?
Yeah, I can follow.
Yes. Okay, good. So this is first step for assessment of loading or indicator reliability for measurements model of reflective construct. For reflective construct, second step is to check construct reliability using different criteria, Cronbach's alpha, composite reliability, or row A, right? So, and also discriminant validity, AVE for convergent validity. To get and to see the result of these criteria, in second step, you have to come to this option, view latent variable coefficient. View latent variable coefficient. If you click on view latent variable coefficient, you can get very good information here. You can see composite reliability, you can see Cronbach alpha, you can see average variance extracted, AVE. So for all construct, CR higher than 0.7, alpha, Cronbach alpha is higher than 7, and AVE is higher than 0.5. So we can establish construct reliability and convergence validity. Okay, and you have one more option, one more result here for full collinearity VIF. So here you have result of full collinearity for all construct. You can see full collinearity of all construct are lower than 3.3. So 3.3 is most conservative, actually the threshold for assessment of full collinearity. So if full collinearity is lower than 3.3, means you can establish discriminant validity if you want to use this full collinearity for assessment of discriminant validity. But here, all construct, all are reflected. So assessment of full collinearity may not be very useful. But if we have spatially formative construct, it can be very useful. And as your friend mentioned, also we can use full collinearity for common method variance or common method bias. So if full collinearity of construct are lower than 3.3, means we can actually we don't have the common method variance issue, right? So you can get this result from this part. Also here you can get very good descriptive information on your construct. You can see a minimum, maximum, median, mode, skewness, cortices. So you can use this skewness and cortices for assessment. Result is based on construct, not based on item. And also you software actually provide several criteria or several methods to report and to check normality of construct. So you can see in some area, maybe some of these criterion is more well-known or useful to assess normality. So based on your area, you can choose some of these actually the method or a criteria to assess normality. And also here you can see histogram. For example, for community attachment, if you click on histogram, so this is histogram of community attachment, right? So you can see based on this histogram is not normal. Also, you can see the result of For example, cortices is higher than 2, right? But based on these two methods is normal, but based on these other two methods is not normal. So WarpPLS provide different methods to assess multivariate normality, right, for construct. So if you want to report normality in your paper and your thesis, you can directly get the result from this table. Okay. So here we can check quality criteria for assessment of measurement model of reflective constructs. Okay. So another criterion we need to check, another things we need to check for assessment of measurement model is discriminant validity. Right? For discriminant validity, we have actually in this part, indicator loading and cross loading, we have cross loading. So, but actually cross loading is no more acceptable criterion for assessment of discriminant validity. But if you want to use this criterion, you can get from here. But if you want to use Fornell-Larker criterion, after view latent variable coefficient, you have another option here, view correlation among latent variable and errors. So for correlation among latent variable, you have two options. And the first one is correlation among latent variable with the square root of ABEs. So if you click on this one, here, for each construct, within bracket, you can see a square root of ABE, square root of ABE of community attachment. And in other part, you can see correlation between community attachment and other constructs. Okay. So you can get result of Fornell-Larker criterion from here. For based on Fornell-Larker criterion, if square root of ABE the higher than correlation of each construct with other construct, it means we can establish discriminant validity. Right? So this is a result of Fornell-Larker criterion, result of assessment of the discriminant validity based on Fornell-Larker criterion. But what about HTMT? WarpPLS 3 actually this option HTMT was added in WarpPLS 3. This HTMT was not available in previous version of this software, but now fortunately we have HTMT in WarpPLS 7. Sorry, WarpPLS 7. So now we have result of HTMT for assessment of measurement. But we cannot get result of HTMT from this view. In this view, actually, we can get basic information and result. If we want to get result of HTMT, we need to go to Explore. In Explore, this Explore actually was added, was included in Warp 6 and 7. Warp 6 and 7. And in this Explore part, software provide many different and useful information and result for different types of analysis. So here you can do multi-group analysis. You can actually assess measurement invariance. You can perform full latent growth analysis and a few more options you have here. But to get discriminant validity using HTMT, you need to go to Explore Additional Coefficient and Indices. So when you click on this one, in this part, you have three options. Some more information about fit indices and fit and quality indices, reliabilities, and discriminant validity coefficients. If you click on discriminant validity coefficient, okay, here you can see result of Fowler-Larker criterion, and this table is diagonal. You can see square root of AVE for each construct and correlation with other construct. Here you can see, and you can get cross-loading. Okay, and here you have HTMT ratio. Okay, HTMT ratio. So you can check the result of HTMT and you can compare with this threshold 0.85 and 0.9. In our model, you can see all the HTMT ratios are lower than 0.85. So using more conservative threshold, we can get acceptable HTMT and established discriminant value. Also here, you can see the result of significance of HTMT ratio. Significance of HTMT ratio equal 1. So actually the hypothesis here, HTMT equal 1. So here you can see the result. If p-value is lower than 0.05, means reject this hypothesis, and you can conclude that your HTMT is different with 1, lower than 1. And here you can get addition to p-value, you can get confidence interval result. So confidence interval result for each construct, lower level and upper level of confidence interval, should not include 1. So 1 should not be included, right? Should not fall within this range, lower and upper level of confidence interval. So you can conclude that based on these criteria, you can establish discriminant validity and one question, when we actually for HTMT, when we should use this threshold, the 0.85 or 0.9, and when we use this significant more liberal method and threshold. When based on literature, your construct are supposed to be similar somehow. Okay, for example, you have satisfaction and loyalty, and in your context, in your study, these two constructs are supposed to have some similarities. So you can use this more liberal method, and here only you need to check HTMT with 1. But if you are confident that your construct are distinct and you actually have different construct, you can use this threshold 0.85 or 0.9. Okay, so this is so here in WarpPLS you can get these 3 criteria for assessment of discriminant. Okay, so this is for assessment of measurement model. What about a structural model? If you click on, if you come to this page, here you can see the result of a structural model. For assessment of a structural model, we need to check R square and we need to check significance of path coefficient, effect size, and Q square. Okay, so if again we go back to view latent variable coefficient and click on view latent variable coefficient, okay, here you can see R squared and adjusted R squared. So in one run and one time performing analysis, you can get all result for assessment of measurement model and a structural model that you need. Okay, here you can get R square and also Q square. Okay, here's Q square. In some software to perform to get Q square, we need to perform blindfolding in other. So we run one more time to get this Q square. But here in WarpPLS, you can get all this information in one run, right? So here you can get R square or adjusted R square to assess structural model, and also Q square to assess predictive relevancy of your model. So this is two criteria. For other two criteria, we have to go to path coefficient and p-value, this option. If you click on path coefficient and p-value, here you have result of path coefficient and the p-value for path coefficient. So you can see all hypotheses except the cultural attitude. The effect of cultural attitude, path coefficient is minus 0.018, and the p-value is 0.358. So this hypothesis cannot be supported by the result, right? But other hypotheses can be supported. So here you can get path coefficient and p-value. And if you go to next option, you can get standard error and effect size for path coefficient. So here you have F square. You have F square for the effect of each construct, each exogenous construct on support. So here F square for community attachment support is 0.023. For environmental attitude is 0.182. For community, for cultural attitude is 0.005. So you know, if F square is lower than 0.02, it means even the hypothesis is supported or p-value is lower than 0.05. So based on this F square and F square lower than 0.02, we cannot support this hypothesis and contribution of this construct on R square of dependent variable or endogenous construct. So here you can get F square. So from this part, these two, you can get path coefficient, p-value, and F square. And from here, latent variable coefficient, you can get R square and Q square. Actually, you can save all these results and open in Excel file, and you actually use the result to transfer to your Word file, your paper, your thesis. So to save the result, you have to click on first option, save all classic model estimates into a tab delimited text file. But WarpPLS save result in text extension or tab delimited file, right? But you can open this file in Excel. Only you need to go to Excel and open this file, so their information in this file will be opened and transferred to Excel. Okay, to save this one, you need to click on and the result. Okay. So now I have the result here. But as I mentioned, this is the text file, but you can open this text file in Excel. So you can get result here. Okay, let me open it in Excel. Okay. You can see my Excel?
Yes, Prof.
Yes, Prof.
Okay. So in Excel, you can open, and you need to go to open and browse, find your file. My file is here. Okay. So okay, but here you cannot see this file because here just can detect Excel file, but you can change to all files and click on your result file. You click on result file. Okay, next, finish. So you can see all information here. And for loading, for weight, if you want to use weight and you have formative constraint, you can get weight, R square, Q square, composite reliability, kernel alpha, average variance extracted, full collinearity. So all information that I showed you in the view page, you can get in this result. Okay. Okay, but now I want to show you something interesting in WarpPLS. One, okay. In WarpPLS, when you perform your analysis in explore part, first option in explore part is statistical power and minimum sample size calculation. So in WarpPLS, using this option, you can calculate minimum sample size based on your framework. Okay, based on your framework. Okay, if I click this one, now you can see this page, yeah, this window. Here, the minimum sample size actually is calculated based on two recent methods that actually these two methods were introduced by Cork and Hadaya, by Ned Cork and his colleague, called inverse square root method and the gamma exponential method. So recent literature in PLS actually suggests these two methods to calculate minimum sample size. And WarpPLS actually calculate based on these two methods minimum sample for based on your framework, right? Okay. In first box, actually you need to key in minimum absolute significant path coefficient. So what's the minimum significant path coefficient in our framework? 0.08. So this is significant, right? 0.08. So the minimum path coefficient, significant path coefficient is 0.08. Okay, so here you need to change this one to 0.08. And power analysis 0.8. So minimum acceptable power for social science is 0.8. So when you click it, okay. So based on these two methods, if you want to accept this hypothesis, your minimum sample size should be 966. Okay. If you change, for example, to second one and you consider this relationship as an insignificant relationship. So the next significant one is the lowest one is 0.16. So if you change to 0.16, so the minimum sample size is 242 and 228 based on these two methods to perform your analysis. So for my framework, for this framework, if I want to use these two methods to calculate minimum sample size, I have to consider first relationship as insignificant relationship, right? And only consider these three as a significant. And the lowest one is 0.16 based on my sample, because this sample is about 400. And minimum sample size for based on this pad coefficient is 242 based on this method, and 228 based on gamma exponential. Okay. So this is one thing that we can calculate minimum sample size using VAR. Another thing, another interesting actually the result that we can get from WarpPLS is this linear and non-linear plot. Actually, one of the main difference between WarpPLS and other PLS software is this option for linear, for non-linear and linear inner algorithm. Okay, if you click on this plot, here you can see warped plot. Warp means care and non-linear. For example, if we click on one of the, for example, relationship between environmental attitude, okay? So you can see the curve, the best curve that fit in our data. But in this case, the curve actually is very close to line. Okay, this is focused curve, but we have many options to see the curve based on standardized data, with data point, without data point, based on unstandardized data. For example, if I want to see multivariate relationship graph based on standardized data, here you can see your data point. And this curve actually is very close to line. So for this framework, there's no significant difference if we choose nonlinear algorithm or linear algorithm, because you can see the curve is very similar or very close to a line. Okay, let me change and show you how we can compare linear and nonlinear. Okay, this is the result that we got from WarpPLS. If we go to setting again, in setting, in first part, I already showed this you this part, outer model algorithm, and the different options that we have. Also, we have inner model algorithm. Inner model algorithm refer to relationship between construct and a structural model. So we can change algorithm for a structural model. Algorithm for a structural model can be linear, can be warp2, warp2 basic, warp3. Linear is linear, similar to other software, similar to traditional PLS. Warp2 actually is U-curve or J-curve. U-curve or J-curve relationship. And warp3 is more complex and refer to S-curve relationship. Refer to S-curve relationship. So we can change this. We can change and we can choose actually the one of these algorithm for relationship between our constraints. Okay, so let me change to linear. Okay, before changing to linear, okay. Okay, we have this one open. And now go to setting, change to linear. Okay, when we change the setting, we need to proceed to a step 5 and run analysis again based on new. Okay, so this is result for linear algorithm. And here also we have result for non-linear algorithm. Warp tree on non-linear option. Okay, you can see some actual changes in R square, in beta coefficient, here between environmental attitude and very, very small changes in the beta coefficient of community attachment, right? But actually community attachment on support using linear option, linear algorithm is not significant. P-value is 0.09. But this one is almost significant. Okay. But the difference between these two options is not very significant for linear and non-linear for this framework. Because actually this framework also curve is very similar to based on data set and data distribution. Curve also are similar and close to line. But if in our framework and our model, actually the relationship, real relationship, be nonlinear relationship and curve relationship, you can see significant difference between path coefficient and also R square when you apply linear and nonlinear algorithm. Okay, let me just very quickly create okay. You can see this paper. You can see this paper published in Journal of Destination Marketing and Management.
Yes.
Okay. Actually, in this paper, we explore relationship between positive perception and negative perception of resident on support, but in two ways based on 3 data sets. One time we apply linear algorithm and non-linear in another one we use non-linear algorithm and we compare the result. For example, for this case, Langone case, for this data set, you can see really significant difference between linear algorithm and non-linear algorithm, right? So you can see here R square is double and the value of path coefficient is significantly changed, especially for negative perception. Okay, when we look at the graph from these two, for example, for second one, this is the graph, and for positive, this graph for positive perception, and this is the graph for negative perception. So you can see the graph of negative perception actually is U-curve, not line. So this is the reason that in previous studies, you can find contradictory results. Some of the study, including my study in different cases, sometimes we got actually negative relationship between negative perception and support. Sometimes researchers get non-significant result for the effect of negative perception on support, and sometimes even positive relationship. What's the reason for this contradictory result? Right? Conflicting result. One of the main reasons for this conflicting result in the literature is non-linear nature of relationship. Actually, this result in the literature was the main reason that pushed us to do this study and find the reason for this different result in previous studies. Why some study actually found the positive, some study negative, and some study insignificant. So this is the reason that we actually explored and found, and this is because of non-linear nature of relationship between negative perception and support. But actually, when we apply non-linear, we should be very careful, because interpretation of path coefficient for non-linear is different with the linear. So if we choose non-linear, we have to actually see the plot and interpret the result based on plot, based on a graph of relationship. So you can get the graph here. Okay, if the, let me very quickly, I create another framework, simple framework based on this data that we use in this paper. We have three main constructs here: positive perception, negative perception, and support. Okay, so create link. Okay, so if we run this framework, perform analysis. Okay, in this framework, here you can see the result, but let's check what's the setting for this result. Here, this result is based on WarpPLS, right? So, okay, let me open this result and keep it. If we change this result to linear, okay, so here you can see really significant difference between R square and also path coefficient between these two. R square for this one is 0.23, but for this one is 0.11. The value of pad coefficient is 0.12, but here is 0.24, double. Okay, for pad. Okay, now let's go through plot, but because we apply VARP3, we need to check the plot for negative perception. Okay, you can see the plot, really a curve plot, U-curve plot. And if we want to get result based on data point, okay, you can see, it means when you get this plot, how to interpret, it means until certain level of negative perception, until certain level of negative perception. Actually, residents with the negative perception are against of support of tourism. So the relationship is negative. But after a certain point, for the people that are more negative, this relationship is positive. Why? It shows that people with higher level of negative perception, they actually interested and they are willing to support tourism and involve in the process of tourism to what? To minimize this negative impact. So the people until certain amount, certain value of negative perception, just they decide to not contribute or support tourism. But after this certain amount, people decide to contribute and support and correct this process. So this is something that we can see in and we can interpret here. And there is one option for this nonlinear plot. Second option, focus relationship graph with segment. If we click on this one, actually we can see non-observed or unobserved heterogeneity. So here we can see beta coefficient for until certain amount, beta coefficient is almost minus 0.36. But after this amount, beta coefficient will change, right? And will be positive, not negative. So based on this, we can see unobserved heterogeneity. So if we use a nonlinear algorithm and we have support from the literature, we have to check the plot and interpret the result based on plot. Okay, so this is for today and only the quick review of assessment of measurement model and structural model and some feature that actually differentiate this software with other software and some feature available in this software. Okay, now I'm here if you have any question.
Hello.
Yes. Still use, right? We cannot hear you.
And I have a question.
Okay, go ahead.
If I want to get the result for linear plot, it means I have to doing a setting in WarpPLS first and choose the linear for the
Yes.
algorithm.
If you want to get result of linear, you need to go to setting.
Mm-hmm.
Setting inner model algorithm change to linear.
Okay, thank you. Thank you.
Yes, go ahead, please.
Yasir Rasool, I'm a PhD scholar from Pakistan. I have a question relevant to sample size, right? as you mentioned that we in this software we can determine the sample size for our specific model, right? As far as your model is concerned, you have five exogenous and one endogenous construct. I used G-Power software in order
Mm.
to determine the sample size, and
Yes.
it gave me the sample size of 92 with the same specifications. And
Okay.
as compared to and if you compare these results with this software where WarpPLS gave the sample size of almost 246, and there is a huge difference in these two sample
Yeah,
sizes.
because they apply two different algorithms. In
Right,
WarpPLS, actually they applied two most recent algorithm and method recommended in the literature by Koch and Hadaya, inverse square root method. If you look at the recent guideline for PLS, you can see these two methods, and recent guidelines suggested these two methods. But it's your option. You can go for G power and use G power. But actually, the different result is based on the reason is because they use different methods.
right. So one more question addition to that. Both are preferable. You said G power can be used and this one. Which one would you prefer? And because the G power is as per my limited knowledge is concerned, G power is being used in most of the papers. This one is the latest recent development, you can say. So but the sample size requirements are entirely different. For primary data, when you want to collect a genuine or real data, collecting bigger sample sizes becomes a challenge. So in as compared keeping that thing in mind, so though I would prefer, that's my suggestion, I would prefer G power more, uh, you know uh, preferable as far as my suggestion is concerned. What do you say about this?
It's up to you. You can use G power. Uh, Also, in many of my studies and paper, I use G power and reported the result of G power. But but these two methods actually are recommended by literature and by especially recent literature. So it depend on which one you want to follow.
If okay, it means if you use G power, then it is acceptable for publication, right?
I use it and the reviewer accepted.
Thank you so much. Thank you.
Okay. But actually the literature, recent literature suggests these two methods for PLS.
Okay, I will inshallah definitely use this one. Thank
And
you.
these two methods are more, actually more conservative. Okay.
Okay, thank you.
Any
Professor,
other
hello.
question? Yes.
Hello. I'm Karzan from Hungary, a PhD scholar also. So thank you so much for your nice presentation and informative
No problem. Welcome.
course. So I just want to ask you about the data that we import for this software. Is it should be the data different for linear or and for
No,
non-linear?
no, no, no.
The
Data
same.
is same, yeah. But the
Okay.
algorithm apply can be different. Actually, the algorithm for a structural model or inner model can be different.
Uh-huh. And the data should be scale measurement, yeah? Not ordinal and not nominal.
Ordinal can be, and the scale also can use, because actually the most of us use the Likert scale, and Likert scale is actually ordinal, right?
Mhm.
But
Yes.
can be used. But the nominal, of course, nominal cannot be used for this type of analysis, regardless of the software or the technique that we use. No,
Okay.
we have to treat in other way. For example, If we have nominal data, we need to create dummy variable and include dummy variable in our framework. So, but the nominal data with more than 2 groups cannot be directly included in our framework.
Okay, so if you don't mind, I just send you an email. I have one question. If you can answer me, I appreciate it.
I will
Thank
try
you.
my best. Okay.
Thank you. Thank you so much, Professor.
Okay. No problem. Okay.